Okay. So today we need to discuss on how.
How part of it?
How part, so how part what you think? Like how you can think whatever the you can say is a read heavy, write heavy,
Ah,
data modeling and data storage decision. This is
mm,
your topic,
mm,
and in this how,
mm,
so how you will decide that? What's your approach?
mm.
Let's say talk about database. How you will decide which database I need to take?
Ah,
I'm
okay.
asking.
Right, right, right. Okay. 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 If I want to uh, say do a typical or okay in our project, what we want customer details, we want order details, we want payment details, and then we want the delivery details and the inventory. This type of system is a classic case for an database, which is nothing but an RDBMS database. For example, say Oracle or MySQL or Postgres, SQL Server. So where you are avoiding the uh, redundancy. You are creating the tables and then build the relationship among the tables and see to that. All this whatever information you want to store and then retrieve can be designed. So this database can support say millions of records. Then later, depending on the need, maybe it can be go for distributed and databases or how many other things are there. Otherwise, for basic ordering of online items, payments, inventory, delivery, dispatches, we can go for a relational database management system where initially it is more of like writing and then retrieval of data. Both are there. Then yeah, and it which database which can support concurrency like multiple users at the same time ordering the items and then delivery tracking, updating the inventory. For all this, I think the database RDBMS is quite robust today compared to 10 years back. So we can go for this type of database. The other database, I don't have a knowledge. For example, NoSQL or maybe what Redis. No, I have not at all worked on that or seen that any demo. This extensively I have worked. So I feel for our application, a simple RDBMS is sufficient.
Okay. So basically, when you go for how,
Hmm.
means for storage thing means how we need to decide
Hmm.
when we're gonna take more model, data model and storage decision.
Ah,
Then we need to take this approach.
ah,
First, how to identify. This is your first question.
ah.
Question: how to identify access pattern?
Hmm.
How we will decide access pattern?
Okay.
So write down actual API use cases, no
Ah,
tentative. What are the actual use cases are there?
ah, ah.
You need to write down that only.
Okay.
First thing first.
Okay.
Otherwise, normally what we did,
Ah,
we follow these. Now we will talking about the entities. How many entities are there? What is the relationship there? So rather than thinking entities,
ah,
we need to think about you can say actual API use cases. Use
ah.
cases.
Okay.
Okay, based on a maybe use case like this.
Ah,
Get me know based on a restaurant ID. Am I right?
Right.
and order, post order. When you are means user want to uh, place a order
Place the order.
and he want to get a information based on ID
Mm,
and track based on order ID.
mm.
You need to think of actual use cases.
Right.
Okay.
Right.
Then convert API's queries. Like then you need to convert API queries.
Mm,
So API get menu,
mm.
read heavy, place order, write
Right.
heavy,
Yes.
track order, frequent
Update.
update.
Correct.
Make sense?
Correct. Correct.
So in this manner, you have a better clarity.
Mm,
Means we need to go with the read or write,
mm,
and what are the kind of operations are there because
mm.
it's a critical decision. Am I right?
Right.
And this is a you can say our API endpoint identify queries, classify read versus write.
Right.
Okay.
Mm,
So in this manner, you have a means clear picture
mm.
what you require. You require read heavy or hybrid or what?
Mm,
Makes sense.
mm.
And if you don't know queries,
Ah,
you cannot design data.
correct. Yes. Yes.
Okay.
Yes.
Then we have queries, and now we need to go with the design schema, query first approach.
Mm,
Here also we need to go with the query first approach.
right. Right.
For each query task,
Mm,
what is the fastest way to serve this?
mm,
Let's say you are running a restaurant or boutique. How you can serve your client fast? Am I right?
Okay.
What you will do so that you will means capture your client or impress your client. Hey, our services means so fast, and we will deliver the things on a time.
Mm,
So get order.
mm,
So bad normalization. Order item plus payment plus delivery.
mm.
Join all the
All the
tables.
tables. Okay. Okay.
Slow.
Yeah. Correct.
Good. Optimize read
Mm,
mode.
mm.
Order ID items this out for delivery.
Delivery.
Single fetch.
Mm.
Makes sense.
Yes.
You can think of means I am means looking for you can say one thali
Mm.
means where I don't need to mm, choose the things or do this thing. I am
Mm.
just simply want means I require some dal, some you can say let's say South Indian thali.
Mm.
I require idli, dosa,
Mm.
and everything in a small quantity should be there. So I
Right.
will go with a thali. But
Right.
you are saying no, I will do separately. Why?
Mm.
So that's why I mean this is a good approach. Am
Okay.
I right?
Okay.
So and other part, this is visuals
Mm.
like user request, um, pre-computer data, fast
Mm.
response. I mean, Thali is a pre-computer.
Mm.
Everything is there. Am I
Mm.
right?
Mm.
Now design for minimum joins,
Mm.
maximum speed.
Speed. Yeah. Right.
This is a rule. Now, how to choose storage type?
Yeah.
You
Correct.
need to tell me means based on which are the which parameter you will consider
Mm.
to go with the storage. I know you don't know, but try to do that. Let me give you a means clue.
Ah.
If you don't know the schema first,
Ah. Ah.
because if you talk about SQL, it's a
Mm.
structure. It's,
Ah. Ah.
it's worked on a structure manner.
Mm.
If you have a one table,
Mm.
that table structure is applicable
Mm.
for all the records.
Mm.
You cannot say, hey, this table means one row
Mm.
is a name or you can say age field optional and another row is required. Or
Mm.
maybe third row require one more property,
Mm.
which is not possible.
Okay.
But in that case, if you require have a different requirement and
mm,
variations are there,
mm,
right?
mm,
Then no SQL data will work.
mm, mm.
Make sense for you?
Okay, okay.
This is a difference,
Mm,
and now you need to tell me how you will choose storage type.
okay. See, my schema will be like this. If you take example of online boutique or restaurant, um, say let's say first I create a user profile. So for all the users, user details, his name, address, phone number, something like that, will be in one separate table. Like for example, customer master table, and then that is that table itself will contain the login details also. Then first, then next, naturally after he creates his profile, he wants to place the orders. So once he places the order, so I'll have something called an order entry table, or orders table, where I will record this order. I'll generate a unique order ID, and then I'll store the. I will assign a unique ID for each customer. So the order table will contain the order ID, unique ID, that particular customer's unique ID, and okay, no, okay, we will come to our masters first. So we have customer master first. The next will be the items, whatever products are there. So I can say items master. So each item will be given unique ID that will be stored in a separate table. When somebody places the order, so it will have a unique order ID, and that customer whoever has placed the order, his customer ID, unique ID, and then the whichever items he has chosen, items ID and the quantity. Now one customer may place more than one order, multiple orders. So that table will contain a unique entity like combination entity, that be something we call it as a primary key or something, where one customer in the same order he cannot have same two items. So it will be two different items. Customer ID will be same, two customer in two different products. The quantity of it that forms the order part.
Okay, now we are not going deep into that. We need to just have a simple approach how
Simple.
you will take a decision.
Ah, ah,
Means what is my need,
ah,
and I need to go with the SQL or I need to go with the this no SQL.
ah,
I
ah.
will need to decide only that.
But correct, Deepak. But here, as I don't have knowledge of NoSQL, I don't know the pros and cons of this one, NoSQL. In if you take RDBMS, yes, instead of having everything in one table, I am going for multiple tables and then join those tables to get my required data. But NoSQL, which I have heard, but I should have done some research on that, but I didn't do. So I don't have much knowledge on NoSQL or for example, Redis, Redis or something. I don't know.
No worries, no worries.
Okay.
So basically, based on this decision framework, you need to ask three questions.
Okay.
Do you need transactions?
Ah,
Then yes. If your answer yes, go with the SQL.
okay.
Do you need flexibility? Yes. Then go with the NoSQL. Do you need massive scale? Yes. Go with the SQL, NoSQL distributor.
In that case, my question will be, what is the meaning of flexibility?
Flexibility, as I told you,
Ah,
your one record is have a different structure.
ah.
Second record have a different structure.
Oh, okay, okay. Oh,
As I told you, this NoSQL give you this flexibility.
okay.
Let's say we all are human beings. Am I
Okay,
right?
okay,
And some are using their last name or middle name as well. Am I right?
okay.
Some are not using.
Correct.
Makes sense.
Ah,
So in a SQL, you need to be, even though you need to make it optional, but those should be there.
okay.
Makes sense.
Right.
And maybe someone have a two bungalows, but
Mm,
you have only one bungalow.
mm,
Makes sense.
mm,
Or someone have a, you can say, car,
mm.
and car have a, you can say, someone don't have a car.
Right.
how you will serve this use cases in SQL, because they are they are based on a structure only.
Structure, correct.
But here it's flexible. Okay,
Hmm.
let me show you.
Yeah, just show me once because I'm slightly getting confused because as for years I've been working only on structured data. So this is slightly confusing for me.
No worries, no worries.
Yeah.
Let me show you. So this is a, because it's a kind of documentation. Okay. With the help of that, you are able to see, means you can add the change the things without any problem.
Right.
So
Customer name, properties, storage size, data size, documents. Okay. Okay.
no, this is not a thing. I'm just showing you. So here you are able to see.
Ah.
These are the you can say some properties there. Okay.
Okay. Right.
And let's say in a SQL,
Ah.
if you will change anything,
Hmm.
okay,
Hmm.
then you need to, it will impact your
Ah.
all the record.
Okay. Yes. Correct.
Am
Correct.
I right?
Yes. Yes.
But here, let's say you need to add it this only.
Okay.
Means you have a special use case
Okay.
where you need to add something here.
Oh,
Makes sense.
okay.
So what you will do, you can say this, let's say I will require a special case.
Ah.
I'm just
Right. Right.
writing
Got
this.
it. Got it. Okay.
Okay, special case, what I require there. Okay, and special case I require hello Sridhar. Okay, Sridhar, and let me update. You are able to see
Yes.
it. You are able to is adopting very easily and not complaining about this
Ah.
other. But in a
Okay.
SQL, you cannot to do that.
Okay. Okay.
This is a flexibility.
Oh. Okay. Okay.
Let's say you are means creating a, you can say, uh, application
Hmm.
where, means even though you will get a clarity of the requirement,
Uh-huh.
but means user want a scalability,
Ah.
and in a scalability, what you require? You require flexibility.
Right.
Tomorrow, if user want to increase 10 field in your
Right.
database,
Right.
okay, and maybe they want, hey, five means for same record or same entity,
Hmm.
means this, for this particular use case, this is applicable, for this particular use case, this is not applicable.
Right.
Makes sense?
Right. Right.
Then what happened?
Hmm.
You cannot do that
We
with a
cannot do another
SQL.
thing. No, we cannot. Yes. Yes.
In a SQL, but if you will going to do that, it will mean impact your performance, because you need to means struggle how you will
Yes.
handle that use case. And
Yeah.
if either you will means kept all the properties, and somewhere you will use for put a
Yes.
null and
Yes.
not null, maybe somewhere they will say, hey, these things are required, somewhere it's not required,
Yeah. Correct.
but those things are there.
Hmm.
Makes sense.
Correct.
And when you will go for query, then it
Hmm.
will also impact,
Impact. Yes.
because those things are there
Correct.
which you don't require.
Yes. Correct.
Makes sense for you.
Correct. Correct. Right.
Now you have some glimpse of this NoSQL.
Yes. I have. I have now. Yes. Okay.
Okay, now you cannot say, means I don't have know anything about this.
Yeah. Okay.
Okay, so payment like PostgreSQL.
Mm.
Order because it's a required transactions.
Mm. Mm.
What do you understand from transaction?
Transaction, for example, somebody places an order, he does a payment. So I record the customer ID, the payment ID, what is the amount, all that details are stored. That's a transaction is made.
In a normal term, let's say what is the mean of transaction and what are the states of transaction?
Okay.
I'm
They,
talking about that. I'm asking for that only.
okay. Okay. States, the initial state will be not paid. Once the payment is successful, it will come to be paid. Sometimes it may be yes paid, but for due to some reason it is in pending state, then it becomes paid.
Sorry, pending state and it will become paid.
But once the transaction is completed, once they get the acknowledgement that his money has come, then that state will be changed from pending to paid. In some cases, there will be pending, but due to some network issue or something, there will be a state called pending. Once that is all clear, then if everything is from the required amount is paid, that in the transaction, then it becomes the paid status. So first it will be no, not paid, pending, paid. These are three states. That means we are getting an agreement that I am paying this much amount. You give me this product. This is the transaction taking place between a customer and the uh, say e-commerce company.
Yes, as per my understanding, you are right for this transaction thing, but as per my understanding, either it can be happen or it cannot be.
Uh,
Because if payment is failed, it's completely failed.
mm,
Doesn't matter how many steps are there.
ah,
Makes sense.
okay.
If done, it's a successfully done.
Mm,
We cannot say, hey, means otherwise what happened? Transaction is going on, and your client is saying I have paid, and you are saying I have not received.
ah, 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 ah.
Makes sense.
Oh,
Acid rule is applicable there on
okay.
transaction.
Ah, okay, okay.
If you can say on some point of time or on some step is failed, it's
Mm,
totally failed.
mm, mm, mm.
It's not a partially failed. It's
Right,
totally failed. Makes sense.
right, 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 right.
These are the some property as per my understanding, which we
Mm,
need to consider.
okay.
And SQL is the best for that.
Ah, right, correct.
Am I right?
Yes,
Because you know SQL more means, and you have experience there more than me, so you can help correct me if I'm wrong there.
correct. Right, 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 right.
So I know need to know that thing only from you.
Okay, okay.
Okay.
Right, right.
So choose based on a problem, not popularity.
Mm,
Okay. So this decision means influence from your use case
mm,
or problem, not for popularity.
ah,
We cannot take a decision. Hey, today nowadays everyone is using this
right,
SQL.
right. Mm, mm,
Okay. So that you need to do that. How
mm,
to handle read heavy system?
mm.
How? Okay. How to handle a read heavy system? What you will do?
No, you simple. Even in Oracle, see, frequently used records or data is stored in a cache, and then instead of every time going and searching in the hard disk, we quickly retrieve it. I mean, not we. That is, it is designed such a way that frequently accessed rows are all stored in the cache. So cache will be extremely faster. So from the cache, it will get picked up and then displayed to the customer. So in that way, we can we will say this is read heavy. Let's say we have too much of read heavy systems. So frequently used records are stored in a cache and then executed.
Okay. So one technique is caching.
Cache.
Okay. Anything else?
Apart from okay, apart from that, we can say partitioning, like huge database, we can partition based on say year or category or month or region. So when we go for the partition, so only based on that query, only that particular partition data is read and then quickly retrieved. So in that way, so one is cache, the other one is partition based on various entities. So
Okay.
these two I can think of 1 minute. So you have cache. So by partition, you are minimizing your search area range. Mm, what else? In some cases, I may need to store that is generally redundancies to be avoided. But in some cases, I need to have redundant data in a table so that I avoid the joins. I avoid the joins. For example, customer ID and order ID is in one table. For customer name, I go to customer master, pick up the name, and so there I have to join two tables. So in some cases, what I might decide is I will include the name also in the order ID table so that I avoid one join. So that itself will again boost my query performance. So depending on the use case, depending on the need, I decide to go for normalized tables or denormalized tables. Having the pros, having studied the pros and cons, we go for this type of techniques.
Okay, let's check that. To add caching, you're right.
Right.
Okay. User cache DB.
Mm.
Okay. Now add replica, you're also right.
Mm.
Primary DB, read data, read replica,
Mm.
and denormalization.
Yes.
You can say minnow plus rating together,
Mm.
order status together.
Mm. Mm.
You means avoiding joins. You are avoiding joins there. Am I
Mm.
right?
Right.
So now you are thinking like an engineer. I'm
Mm.
happy to
Mm.
see this change.
Okay.
Okay, now write heavy.
Okay.
You need to.
Right heavy. Okay. How to handle the uh, right heavy? So here, what we can think of. So huge right operations are taking place. So data was already there in case of read heavy. In this case, you are writing. So how to speed up the writing? Mm, eh, I think, I mean, I don't know, I'm not sure, but mm, by having uh, high speed hard disks, I don't know, not sure, 1 minute. A normal term, how we can think of, mm, okay, can you just give me any clue, Deepak, like right heavy?
Yes, means we need to, let's say, rather than you can say serving, now we need to prepare the food. Makes sense. You
Ah,
can think of earlier we are preparing everything and just we are responsible delivery. Makes sense.
ah,
Like you are preparing food already, some of the parts, and
mm,
whatever is not means you cannot do that. You are doing that instantly. Makes
mm,
sense.
mm,
Like chopping, you can already done. a kind of cache you already. But here we need to prepare the food.
Okay.
How you will, what are the changes you require, how you will
Ah,
think of. Now we, this you can say shift change. Makes
ah,
sense.
ah,
Earlier you are responsible for delivery.
correct.
Now you are responsible for, you can say, preparing the food.
Okay. Okay. Ah, okay.
Now you can think what you require so that you will serve better or handle your customer better. You can think of earlier you are running a restaurant, now it's a catering order.
Uh-huh. Okay, in that case, what I will do is I will hire few more cooks, and then I will hire. I will streamline the ordering process. Like for example, I will hire few more say staff where as and when the product is coming out from the kitchen, they're responsible for quick packing, and then I'll have a separate counter for delivering. So one is have more resources. Yeah, correct. So, wow, correct. One word is you're going to add more resources based on the uh, um, orders, like heavy orders you are getting. So, as you told, from a restaurant, I became a caterer. So, I may get, and the two, if I become online, I may get huge order, I mean, lot of orders in a day I make, or at a time also. So, what I do first is very more basic thing I do is I put in more resources. That means I expand my resources. What are the resources? First is the cooks. I hire more cooks. I hire more staff to handle the advanced part of the orders. So in this way, I handle the heavy orders.
So simply you can think of, yes, you are right there.
Ah,
You can think of, you can divide a segment as well. Hey, this is a, this will staff will handle veg, non-veg,
ah,
Chinese, this stuff. Makes
ah,
sense. Continental.
ah.
So based on that, you can divide and
Mm,
utilize your power there. Am I right?
correct. Correct.
And yes, you need to increase the power.
Mm,
So at the place of this, you can say, let's say you can do, rather than just instant, you can store in a buffer as well,
ah,
like
ah.
buffer rights. Makes sense.
Okay. Okay.
So what you are doing there, you are whatever means order you are getting, you are storing in
Ah,
a temporary storage. Makes sense.
ah, ah, ah,
And so that your DB can have a means something which they can easily fetch from there, from buffer.
ah. Okay. Okay. Okay.
Makes sense.
Okay.
Batch right, rather than just trying to, you can say this
One. Okay.
at a one at a time to disturb. Why you are not means s- create a batch and go for insertion at a one on a one shot.
Okay. 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 Okay.
Makes sense. And
Mm-hmm.
another is partitioning, which you are explaining earlier.
Right.
Makes sense.
Right. Right.
So now rules, right, should be smooth, not
Spike.
spiky.
Mm-hmm.
Makes sense.
Okay. Okay.
So now question arise how to implement partitioning,
Mm.
because we earlier discussed partitioning is a sharding or partitioning is required.
Mm. Mm.
So how to implement?
Mm.
Now question is this.
Uh, okay. See, again, it depends on the need. If you take e-commerce general inventory or in my products, I may partition based on the region or the product category, or let's say I'm running this online boutique since last 10 years. So I will, what I will do, last say 8 or 9 years data, I will partition, I will archive it. Only the current data I keep. Whatever analytics data I want, those will go into the archive mode. Only when needed, that will be retrieved in the background and then processed. So, overall, um, based on the need, maybe region wise, category wise, I may do the current data. For analytics purpose, I may go for year wise.
Yes, you're right. So based on this hash based is there, you
Oh,
can say range based,
okay,
okay, and other one geo based.
okay.
You can categorize means any nth number of this type, but these are the main. Okay.
Main, okay,
Now I'm not saying these are the only thing. It's
okay.
totally up to you. Means in
Right.
which want to you categorize.
Correct.
So you can think of you have Almira is there and with the self and how you want to organize the things is totally up to you. Make sense?
Right, right, right.
So here order sharding 1, sharding 2 and shard 3
Okay.
rules.
Hmm.
Partitions before scale break you.
Hmm.
So you need to go with the before scaling.
Okay. Here, one doubt I have, Deepak. Partition, I understand very easy, correct. I mean, in a right manner. But what is sharding?
Sharding is the same thing means hey you are have a you can say now you want to serve your customer. Am I right?
Right, right.
If you have only one you can say counter,
Okay.
then at a time how many customer it can attend? That one person is there. Only
Ah.
one. Am I right?
Yes, only one.
If you have a multiple counter,
Ah.
then they can serve multiple
Hmm.
client. So this is sharding.
Okay, okay, okay.
They will just give us same information,
Okay,
but
okay.
now you have a multiple.
Mm-hmm.
Okay.
Okay, okay.
How to handle consistency?
Ah.
Now this is the next question. How?
Consistency, in what way the consistency? Um, for example, either I have 100 products or I have thousands of products. My display time should be always within, say, 20 microseconds, or single user or thousands of users when they log in, within 2 to 3 seconds it should log in and then come and go to the landing page. uh, so every activity, uh, even if I scale or I don't scale, I should maintain the same consistency throughout my application.
Okay. You are talking about this is the only consistency you can think of. You are thinking only on a performance. Hey, this need to be a load. This need to be this. What about other options?
1 minute. General terms. Okay. Example of a restaurant, if you take, the taste, whatever taste we are offering to the customers, that should be consistent. For example, today it's a very good taste. Tomorrow it should not be too salty. Or third day should not be less salt. So whatever taste is good, that same consistency I should maintain throughout. So by this, customers also knows, anytime you go, any day you go, he gives the items with the same taste. So that is a very good example of the consistency here in case of restaurant.
Yes. So how classify data? Strong
Okay.
consistency needed. Payment, balance, order confirmation.
Mm.
If order is done, it cannot be, you can say, change its state. Makes sense.
Correct.
If payment is done, that means done.
Mm.
Even though you are trying, it will not detect a payment again
Right.
from client, you can say account.
Mm.
And this is a strong consistency needed.
Correct.
Two type of consistency, strong and eventually consistency.
Okay.
Consistent, okay. Tracking, notification, analytics.
Ethics.
Means here means consistency required, but it's eventually.
Mm, mm.
Means there are chances. We means we can do that. Mistake
Okay.
are acceptable there, but here
Mm.
no. It's required strongly.
Right, right.
Okay.
Okay, okay.
So critical data, strong consistency.
Mm,
Non-critical data, eventual consistency.
mm, mm.
Okay.
Right, right.
Like strong, consistent, expensive, use only when needed.
Mm.
Okay.
Okay,
So everything has a cost. You need to know
okay,
what
okay.
is the cost and do you require to really you need to do that.
Mm.
Make sense?
Right, right, right.
Sorry. So how to design life cycle?
Mm, mm.
How to design data life cycle? Because we discussed this life cycle, am I right? How
Yes.
you will design.
Okay. The data life cycle is like right from that is it starts with the creation of the data till we remove it or delete it or put into archive. That is so in between a lot of transactions are done based on that data. Uh, is, okay, or okay, in case of say restaurant example, we create a product. Sorry, yeah. For example, in the case of a restaurant, let's say we start doing preparing plain idlis, that goes on for say 1 year. Later, we find that the sales of the idlis are slowly coming down because of various reasons. So people are now having more choices. They want to go for masala idli, some other type of idli. So initially, I created the prepare the idli. Then gradually, I want to now, in a graceful manner, slowly move that product out of my list. Based on the user needs, I decide that okay, not much of sales are happening, but we are putting a lot of effort to prepare that. So, seeing the trend, I gradually remove that product from my menu. So there, the life of
Yes.
that product idli ends. Otherwise, the other case, let's say now, right from day one, there's a product which many people like and they keep coming back for that product. So from creation, it goes on having a huge number of transactions for that product.
Yes.
Right? This is, I think, somewhere I'm near, I think.
Yes, sir, definitely,
Okay,
definitely.
okay.
So basically, you need to just think of four data which
Ah,
you require actively, or warm
okay, all
data,
data. Okay,
recent
fine.
order, and
Ah, ah.
cold data.
Okay, 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 okay.
Makes sense.
Okay, okay.
And after cold, there is a delete.
Mm-hmm.
Makes
Right,
sense.
right. Okay,
Hot, warm, cold.
okay.
Tools, Amazon S3, BigQuery.
Mm.
Sorry. Don't store everything in a primary DB.
Correct. Yes.
Why?
Right, right.
Why? I'm asking why.
No, one simple example, if I have only one table, uh, everything is stored in that table, and tomorrow, for some reason, my table or DB crashes, my entire system, entire business will come on, the business will come down crashing. Instead, if I split my database into multi-database or multi-table, only that area, for example, say payments area TB or my archive table, only one part of the system will be down. So I can continue doing my business. Meanwhile, in the background, I can fix that problem and then again bring it online. So my risk factor is reduced if I go for multi-DB or multi-table architecture rather than putting everything in one basket or in one table. One.
Yes, yes,
Second, right?
yes, you're right.
Okay.
So you can think of in this restaurant,
Ah,
if you are putting everything, your vegetable, raw vegetable and everything,
hmm.
and the spices in a kitchen only,
Ah,
then it's messed up.
yeah,
Am I right?
correct. Hmm.
So for that, you have a different pantry.
Right, right, right,
Makes sense.
right.
Which is have a different responsibility.
Hmm. Hmm.
So same thing applicable here. Am I right?
Yeah, correct.
So that's why.
Hmm. Hmm.
And whatever you told, that's right.
Hmm.
Okay, so now how to design end-to-end system? What are the steps which you learn? Could you tell me?
Okay, how to design end to end. So it has got that four major entities here, four or five. Yeah, user. Okay, okay. In this cache, then order, then queue. Okay, I mean, I didn't think of these things. Okay, fine. So yeah, user I knew, then cache is there. Okay, then orders DB, then queuing, and then analytics. So okay,
Okay,
okay, okay, okay, okay. Okay,
okay, this is a final.
okay. Identify API. Okay, APIs. Then extract queries, right? Classify read or write. Then design schema. Then choose the DB. Then add cache or slash queue. Then partition the data, right? Partition the data and then define consistency. Okay, then define life cycle. Okay, okay.
Final mental model, API query,
Data
data model storage, scaling, optimization.
optimization. Okay.
And first design your data is used,
Hmm.
then decide how it's stored.
Hmm. Okay.
Makes sense. This is an
Right.
important point.
Ah,
Most of the time we will think about a data
correct.
storage, how
Hmm.
you, but before knowing the data and
Hmm.
its nature, how you can take that decision.
Hmm. Hmm. Hmm.
Makes sense. So
Right.
you can say this is a this 2DB is a after design schema.
Ah, right. Okay. 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 Okay.
Okay.
Okay. Okay. Nice.
So do you have any question, concern, or anything which we need to discuss regarding this
No, this is
storage storage one,
no, this is a very interesting topic and more.
data modeling and data storage
Ah,
decision?
so I will go through the recording because a lot of technical and it's a very important topic, in fact. And I'm happy somewhere at the 50% of the answers I was able to give means my thinking is slowly changing. So I need to put little more effort. So then I'll be able to give a polished answer. But this chapter is a very crucial chapter for me. I will go through this and like choosing the database. Yes, maybe in the coming months, if we do some small or a very mini project using NoSQL, then I will be at least able to answer the pros and cons of regular RDBMS and a NoSQL. Some use cases I have to take and then do it. Then I'll get a real picture. Okay, this is how it works. So then I think I am better off.
So for that, on our YouTube channel, MongoDB's videos are there.
Ah,
You can check that
okay, okay. Deepak,
because
1 minute, Deepak, 1 minute, 1 minute.
okay, okay.
ನೀರು ಹೋಗ್ತಾ ತೆಗಿಯೋ ನೀರು ಹೋಗ್ತಾ ತೆಗಿಯೋ ನೀರು ಹೋಗ್ತಾ ಇರತ್ತಲ್ಲ yeah, Deepak, sorry, tell me, Deepak. So,
I
For you telling about MongoDB, right?
Yes, yes.
Okay.
MongoDB is there, Node.js is there.
Okay.
So means if you want to enhance your knowledge and you want to try different things,
Ah.
so on our YouTube channel, lot of things are there,
Oh, okay.
and
Okay.
most of the means is recorded by me
Oh, is it?
only. So you can means if you have any question concern, yeah, then your you can say mentor is already there, so you
Okay.
can ask the question
Ah,
regarding those as well. I don't
okay.
have issue with that,
Okay. Okay.
but you need to put some extra effort.
Exactly. Right. I understand. Yes. 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 Yes.
Makes sense.
Yes.
And if you require access of you can say live code or real project code, then I can provide you that as well. But for that, you also need to have some understanding of that part. Am I right?
Mm-hmm.
Then you can get access.
No, what
Otherwise,
that will keep it a little later. At least once we complete our online my boutique project, then I will spend some time, maybe 1 week to 10 days, just to get to know the feel of that NoSQL. That's
no, no. I am saying you can, if you have a time and you are interested. I am not saying that you cannot do that. You
ah,
can
ah.
go ahead and do that.
Oh, okay.
But I am concerned about this thing which we
Ah,
are doing.
ah,
Means things are there, and I
ah.
really appreciate if you are able to do that.
Okay.
But I don't want any compromisation with our current.
Right, right.
I cannot tolerate that. But
Ah,
apart from that, if you can do a balance,
mm.
then you can do very easily. I'm
Okay.
not restricting you.
Mm-hmm.
You understand my point?
Right, right, right.
And I want means whatever you are thinking now means you can say when you move forward. Now you have a database.
Ah,
Makes sense.
mm.
Why you are not trying with the things in a real manner? You can
Ah,
try that.
okay, okay.
But I am saying you need to end of this 15 module. I want something so that
Oh,
we can represent to our means client or someone.
yes,
Hey,
right, right, right.
this is the output.
Yeah, correct,
I
correct.
want something should be realistic,
Right,
not on
right.
a document only.
Okay, Deepak, got it. I got the point.
I want to see the change,
Okay, 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 okay.
what you learn and which we can showcase.
Right, 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 right.
Make sense?
Right, Deepak, right, right.
Let me stop the recording for this. Okay, so